All right, guys. So, welcome to this three video network series. Today's video one, I'm going to go over basic configurations of setting up devices, connections, configuring interfaces. This network is going to consist of probably just one or two networks, and we're going to configure the VLANs, the trunk port, and the router on the stick configuration. After that, we'll move down to configure DHCP, and I will also configure a static route. So let's get started. We'll start off with 2911 router right here. We'll do another one over here. We'll pretend this is the internal router, and this is one leading out of the network. This will also serve as our DHCP server. All right, so let's find a switch. I could do a layer 3 switch. I'll just do a simple 2960. Put it right here. We have a small network, so we don't, and we're using VLAN, so we don't really need the layer 3 advantage. Okay, here we go. Let me see PCs here. I had initially thought about also including configuring SSH on video 2, but I decided just not include that just because I already have a video showing how to configure that. So I just thought for the sake of time, I'll leave that out. I left out DNS as well. That one's relatively straightforward. All right, so this is what our little network is going to look like. I'm also going to add, yeah, we can use it. I'll just put a laptop over there. Laptop here on this network. All right, so let's start off with connecting the devices. When we're connecting network device to network device, you use the straight through cables. Let's go ahead and go with gig internet Ethernet 0/1. And for simplicity's sake, I'm just gonna make them match so I know which ones are which. So copper straight through. We'll make this 0/0 and 0/0. All right. I know Cisco Packet Tracer has a tool that allows you to basically see what ports are what interfaces are connected to what. But if you hover your mouse over the actual interface, you can see they pop up. So we have gig 01, gig 01, and I'm matching them all. So I don't really need that functionality right now. But in a larger simulated network, it would be nice to have. And you can also just go in command line and see. So let's go ahead and connect the end devices to the switch, and we're going to go ahead and use crossover cable. I will start off with one, fast Ethernet 1, and we'll go all the way down to fast Ethernet 4. You notice a series of green triangles and orange circles. That's basically a functionality of the switch. It's something called spanning tree protocol, and it basically tries to prevent loops, storms, that kind of thing. We'll go more in depth in that later on our video 3. So this is what a very simple network is going to look like. Okay, and now that we have the simulated wires and devices up, let's go ahead before we make any configurations. We will get a set of IPs for this network, and we'll do the easy 192.168.1.0. We'll make it a subnet of /24. And we will also do one for this one. We'll just say 10.0.0.0. Let's make it /30. Put this here. Okay. Now we're going to use a router on a stick, and these are going to be connected via VLAN. So let's just say we'll make this VLAN 10, and we'll name it Home Lab. There we go. All right. I guess I'm making that work there too. But I'm not going to focus on this at all. It's just going to be for step number 4, and to make sure we can ping outside of the network. We'll just say /24. All right. So let's go ahead and get started. We'll start off on router. We'll start off on router 0. We'll get the VLANs, the trunk port, and the router on a stick configuration setup. So right now, we're going to focus on router on a stick. Click on the router. Click on command line interface. No for that. We'll enable the router conf-t to get into configuration mode. And we'll change the host name to router 1. And I'll call the other router 2. All right, so from here, I'll say do show run. I can say do show run if I'm in configuration mode, or I can also, if I'm not in configuration mode, I can just say, if I'm in this mode, I'll say show run. And we can see by default, all router interfaces are shut down. And we want to leave them like that if they're not going to be used. So for example, I don't think I'm using 0/2, so I have no reason to keep that open. No shutdown that. But for now, we are going to just focus on this. I believe that was 0/1. Let me just double check. Hover my mouse over this. It is. All right. So what I want to do here is I will say conf-t to get in configuration mode, interface G0/1. I'm going to say no shut. It will turn on. And notice I didn't have to no shut the switch because by default, switch interfaces are not shut down. So that's actually up and running now. And for VLAN 10, VLAN traffic won't actually flow through this interface. We have to make something called a sub interface if we are using router on a stick, which is what we're doing. So what we will do here to make a sub interface, just recall that the interface that we just opened up was gigabit Ethernet 0/1. I'll say to make a sub interface, you just go same thing 0/1 and then include a dot, and you can use whatever number you want here. I recommend using the same number that is your VLAN. So for example, if you have VLAN 7, make it .7. If you have VLAN 30, make it .30. It just makes it easier to keep track if you have multiple VLANs. So I'm gonna push enter. It will say, you will get a syslog message saying, hey, your new interface, sub interface is up. And while it's up, we still wouldn't be able to pass VLAN traffic to the router. The router wouldn't know how to forward the traffic. So we have to add a bit of data to the header of the traffic packet. And in order to do that, we have to tell the router that on this subinterface, we will encapsulate the data. So encapsulation, question mark, and we'll use .1q, and I'm pushing tab to make it autofill. Question mark again, and this last prompt here is saying basically what is your VLAN number, and if we look over here, we have a VLAN number of 10. So we'll do 10. I'll say do right to save our configurations, and for the time being, we are done with router 1's configurations. I will just change this name to router 1 just to make it. I guess I'll change this one first. Okay, just bear with me, guys. Perfect. I'll make this router 1. All right. So we have our router on a stick configuration set up. And now whenever you have a router on a stick configuration, you will also need it to be connected to a trunk port. And that way, it would basically allow multiple VLAN traffic to be, it would allow the traffic to be divided up and whatever to go to wherever VLAN it needs to go, the traffic. So in order to do that, we'll go to the switch now. We'll say enable. Let's just show it run for now. And we see all these interfaces are up. And we know this is Gigabyte Ethernet 0/1. So let's focus on the trunk port now. So we're going to focus on this one. And in order to make that a trunk, we'll say interface G0/1. So, and then we'll say also, anytime you're working with VLANs and you're trying to make access ports for the VLANs, you use the command switch port. And then if you're not sure what to do after that, push the question mark and you get all these options. We want option switch port mode trunk. And then we can see that it went off for first via the syslog, and it came back on. So basically just reconfiguring itself for a trunk port. All right, so at that point, that's really all we need to do right now at this moment for this interface. So now in theory, this connection to the switch and the router should be fine, but let's go ahead and configure all of these devices with this connection being an access port for this VLAN 10. So let's go ahead and do that now. We'll say interface. Okay, which one did I start with? Okay, so 1 through 4, I'm assuming. Yep. All right, so we could do them all at the same time. Let's just start off with one of them for now. And we use the command interface F0/1. So we're looking at this connection here. Switch port, question mark. Switch port mode, access, and then switch port, access, and then the VLAN number that we want to use for this. All right. Before we continue, I'm going to exit because I actually forgot to make the VLAN in the actual switch. So let's go ahead and do that. Let's go ahead and make the name for our VLAN by typing in VLAN 10. You can see the options here. We want to use the option name, and we'll call it Home Lab. There we go. We're going to exit. And to actually get the VLAN to be up and running, you type in interface VLAN 10. There we go. Online protocol on interface VLAN 10 is up now. All right, we'll exit. And then we'll go to this interface here. So we'll say interface. Actually, since this is 0/1, we know this is 0/2, this is 3 and 4. A way that we can configure these three interfaces at the same time, we will just do one simple change. We'll add range. So we're saying, hey, we're going to work on fast Ethernet X through Y. So in this case, it's going to be 2. Oh, I guess it would help if I typed in this. I'm having a brain fart. There we go. 2. We'll use 2 through 4. And then we'll say switch port mode access. Switch port access VLAN 10. Do right. There we go. You can see all these ports. Spanning tree protocol is doing its thing. It's putting those ports basically on hold for a temporary period of time until it can make sure that there's no network loops. There was one other thing I forgot to do. I gotta go back to the router because the router is going to serve as the default gateway for VLAN 10. And I'm going to give this sub interface an IP address. And this IP address on sub interface G0.10 is going to be the default gateway for all these PCs in this VLAN. And let's go ahead and make it 192.168.1. Let's just go say 1 for now, and the subnet mask. Right, there we go. And now, if I created a static IP for this PC, 192 is the default gateway, is what we just configured on the router. Let's just give this one a static address, just for the time being. 1.10, for example. Subnet mask is /24. Perfect. I should be able to ping the default gateway and vice versa. So let's try it. Boom. There we go. As long as you get this message with the time to live at the very end, and you can see the packets received, it's a 0% loss, then you know it's working fine. Let's just make sure we got connectivity over here as well, which it should be. 192.168.1.10. And there we go. We know our VLAN is set up correctly. And we can use a few commands as well to see. You show IP interface brief. This will show us all the interfaces that are available. And we see VLAN 10 at the very bottom is in an up state. That's what we want. And we are only using fast Ethernet 1 through 4. So I can actually shut down all these if I'm not using them. And that will decrease our potential attack surface. In theory, just hardening our network. So I'm going to go ahead and shut these down. So in order to do this, we'll use the range command again. So I'll say interface range. And let's go ahead and start off. You can always turn these back on if you do extend your network later on in the future. Interface range from 5 to 24. And I'll say shut. And that's going to bring all these down. All right. Oh, I probably should save. So do right. There we go. And if you remember, the router's interfaces are down by default, so we don't have to do that on routers. All right, so let's go ahead and make a connection to this laptop. So we will go ahead and just, I guess I need to switch to switch. I'm just making it 2960 here. Boom. Boom. There we go. And packets. Cisco Packet Tracer You can also use this option, automatically choose connection type, and it makes your life easier. You go boom, and you can do the same thing with switch to the laptop. There we go. All right, so now that we've added this, we're still going to ignore this for now. You'll see why I added this though later on. It has to do with step number 4. All right, so let's go ahead and configure this interface here. What we're going to do on these interfaces is we're going to configure an IP address for this interface facing this router and this interface facing that router. So let's go ahead and go into router 1. Let me just double check which interfaces these are. Okay, 0, 0, perfect. So exit interface G0/0. I'm going to say no shut. You can see even though we push no shut and turn that interface up, it's still red. That's because this router is down as well. And if one's up and one's down, it will still have the interface connected down. So let's go ahead and just configure this IP address. So we'll say IP address 10.0.0 .1. Oh. I'm gonna say 255.255.255.252. Do right. Since this one's .1, we'll make this one .2. So we'll go to router 2, command line interface. I'm gonna skip initial dialog, configuration dialog. Enable conf t, host name. We'll make this router 2. Do right. I still got to configure a host name for the switch. All right, so let's go ahead and configure the interface G0/0. We'll say no shut, brings the interfaces up. There would still be no connectivity here though, because this IP address hasn't been assigned yet. So we'll say IP address 10.0.0.2, 255.255.255. Oh, sorry, I was using. Do right. Just make sure I didn't put the wrong IP in this. Okay, good. So now I should be able to ping the other router. Do ping 10.0.0.2. There we go. 80% for the first time. It has to do a process to discover the router first. That's why it loses the first ICMP message. Second one gets 100%, and so forth. So we know the routers can talk to each other. There we go. Perfect. All right. So let's go ahead and configure DHCP. This is going to serve as our DHCP server. In order to make a DHCP server for using the router, we'll say IP DHCP. You can say question mark. We'll go to excluded address. The excluded address is basically saying, hey, I know my devices are going to automatically get a IP address that is in a pre-configured amount of IPs. We don't want to use IP addresses X to Y. So basically, you wouldn't want to give your network devices dynamic IPs. They should stay static. In case they ever change, your devices will not be able to find them. So let's give ourselves, we only have 2 network devices in this VLAN or subnet. We want to include more than that in case we want to expand in the future. So we'll say 192.168.1.1 1 through 192.168.1.10. Say do right, and then we'll say IP DHCP pool, and the pool is going to be the IPs that we want to use. So the pool name is going to be home lab. I'll say question mark. Okay, and then as you can see, the command line interface changes slightly. Now we're in basically configuring this set of IPs. We'll say question mark again. We don't really have these two right now because I didn't set up a DNS server. That's okay. We don't really need it right now. We'll set up a default router though. So we'll say default router. It's going to be the same. It's going to be the same IP that we set up the default gateway for these end users. So it's going to be 192.168.1.1. All right. What else can we do? We will set up the network. So this is where we say, hey, I want to use this network and I want to use this amount of allocated IPs. So network is going to be 192.168.1.0. I believe it's going to ask me for a subnet, which it will. Network mask and subnet, the same thing. Do right. So that should be all I need to do here. I don't have any options I need right now, so we'll exit. Do right. Now we also have to configure, since this is on a separate network, we have to configure an IP helper on our actual network that we are going to get the IPs from for. And we want to configure this router since it's in the subnet, the network. We are going to configure interface G0/1. But since this is using a VLAN and we are using router on a stick, we want to configure that sub interface and not this actual interface here. If we would put the IP helper on Gigabyte Ethernet interface 0/1, it wouldn't actually do anything. So let's go ahead and go to the sub interface. And we'll say IP, I think it's IP helper address. Let me just question mark so I can make sure. Yep, so I can push tab. And the helper address is going to be the IP that we had assigned for VLAN 10's default gateway. So it's going to be 192.168.1.1. Do right. And what do you think? Do you think now if I try to get a IP dynamically with this PC, do you think I'll be able to get it or no? Okay, let's find out. I'm going to click on desktop, command prompt. I push ipconfig. You can see we have nothing. I'll push ipconfig renew. And it failed. But that's okay. What's going on here is now these routers are connected via this interface, but this router is on a totally different network than the VLAN that we are using for the home lab, and it doesn't know how to reach this network here. So what we want to do is we could configure a dynamic routing protocol, but I figured instead we'll just do a static route for now, and in a later video we will just upgrade or change it to OSPF. So let's go ahead and configure a static route telling traffic to get basically to this destination. You have to go this way, X and Y ways. So let's do that. In order to set up a static route, we'll say IP route question mark. And the destination prefix. So basically it's asking, what network are you trying to get to? So we wanted to go to VLAN 10 to talk to these PCs. We want to go to this network. So I'll say 192.168.1.0. I'll push question mark again. What is that destination's subnet mask? It's going to be /24, so that's 255.255.255.0. Question mark again. And basically, how is it going to get there? What's the next hop? And we will say, since we are connected to this router, our next hop is going to be, it wouldn't be this because that's where we're at now. Our next hop to get to this destination is going to be this interface. And if you remember, that's going to be, this is .2, so this is going to be 10.0.0.1. So 10.0.0.1, do right. All right, so I have a static route configured. DHCP should work now. I have this set up here because usually with any kind of like route configurations, you would want to configure a two-way IP route. So I would configure an IP route here to basically get traffic that wants to reach the outside network to go flow through this way and be able to reach its destination. But let's go ahead for the sake of seeing if DHCP works. We'll see again. I just pushed the up arrow to basically do the same prompt that I had tried to do again. I'll push enter. DHCP request failed. Okay, so let's see what's going on with that. So we have the IP route. Let me just see. Can this router talk to 192.168.10? Okay, so I know that traffic can flow this way and reach these PCs because remember prior we set up a static IP address for this computer. So, and it's okay if you run into issues like this. We basically just have to figure out where your issue is. And I'm thinking since there is connectivity here, it should be able to flow. It must be a misconfiguration that I had made with either the VLAN. Actually, I don't know. It's probably going to be a misconfiguration with DHCP. So let's see what we have going on here. Let's take a look at this, not the switch. Let's take a look at router 1. And I'm going to say do show run. And I'm just going to look, make sure everything looks fine. Okay, so if I look at the sub interface here, I don't know if you can see a mistake. There is a mistake in here. And pause the video, see if you can figure out what it is. Okay, so the mistake here I made, and it's going to be this IP helper address. It's not supposed to point to the default gateway of the VLAN. It's actually supposed to point to the DHCP server itself. So it's easy to fix. What we will do is just say we can actually just copy and paste this into our current. From here, I'm going to say Control and A to get to the front of this prompt, and then I'm going to say no. And what that does is if I say do show run, You'll see now that it is gone. There's no IP helper. So I'm just going to add it again, a tab, and I'm going to make it the IP address of our DHCP server, this interface here for the switch, for the router, I'm sorry. Do right. And now, honestly, the DHCP request should work. So let's see what we got here. I'm just making sure I got the right. It should be .2. Let me just make sure. Do show IP interface brief. Yep, perfect. All right, I'm gonna have PC1 try to get an IP address. So I'll say IP config to see what my IP configurations are. Everything shouldn't be 0. Yep, perfect. Oh, I just got an IP address. So it gave me the IP address of 11. Do you remember why it didn't give me anything smaller, like 1 through 10? Yeah, and that's because I set up a excluded address pool for my network devices. But yeah, that's basically all you have to do to set up the DHCP. It's pretty straightforward. And you can also, if you don't use the command prompt, you can just go through the configuration settings, click DHCP. You'll see our default gateway gets filled out. If you go to Fast Ethernet, it has provided us with .12. This one's probably going to be .13. And if I wanted to, this one was statically set up. If I wanted to get a DHCP address here, all I would have to do is this. IP config release. Oh, okay, I guess I was mistaken there. That makes sense though, because it isn't using IP config release is using DHCP, so I can just click on that. All right, and that's it. Oh, one other thing. To be able to talk to the outside world, I have one-way communication for this IP route. I would also have to make an IP route for this network. So traffic here knows how to get to here. Because if I try to ping, let me just make this a static IP address here. If I try to ping this, it won't work. We'll make the default gateway this interface here. So that's going to be 0/1. Let's go ahead and say interface 0/1. We'll give it an IP address of 192.168.2.1.255.255.255.0. Boom. No shut. Do right. Okay. Alright, so that's going to be the default gateway of this laptop. So 192.168.2.1, and we'll give this laptop an IP address of 192.168.2.10 with a subnet mask of /24. Perfect. Let's just make sure I can reach the default gateway. I know if I can't reach the default gateway, it's not going to work. So it's best practice just to test it now, you know. Boom. All right, so we know the laptop can talk to the router. Perfect. Just to make sure two-way communication is possible. 192.168.2.10. Perfect. All right, but let's, for example, without the static route from this network to this network, you'll see that it can't actually talk to that laptop yet. So I'll say do ping, or actually just ping this time. This is what you would see. Destination host unreachable because the router doesn't know how to forward the traffic. So we'll just go to router 1. We'll say exit IP route. And we will say, sorry, I got my dog over here. She's baby. We will say 192.168.2.0, subnet mask of 255.255.255.0, and our next hop. So it's not going to be anything connected to this router. Our next hop is here. So we'll say 10.0.0.2, boom, do right. Oh, shoot. I can't remember to get out of that. All right, so let's just see if we can talk to the laptop that's hooked up all the way across this network. It should allow us to ping 192.168.2.10. There we go. That's it. Well, everyone, thanks for watching. That's going to be all for this video. And yeah.